In this video, we're going to talk about volume of pyramids and cones. So the formula for the volume of a pyramid, now remember volume means as if you're filling the solid up, so it's going to be 3D. So the volume is 1/3. Big B is always represents the area of the base, and then you times it by the height. Notice it says height. We talked about this is called the slant height. That's there's an L here. So you're looking for that vertical height for volume. Okay, so let's look at the first one. So the formula for volume, 1/3 times the area of the base times height. So my volume here, I need to find the area of the base. So let's identify the shape of the base. The base here is a rectangle. So the area of a rectangle is length times width. So for the big B, we're going to do length times width. We'll have 21 times 9. So big B, so the area of the base will equal to 189. So let's plug that in now. 1/3 times 189 times the height. Now the height you're looking for is vertical. So there's only one that shows us right here. So the height here is going to be 5. And now you go ahead and multiply. Now remember 1/3, you're multiplying by 1/3. It's the same thing if you're multiplying these and dividing by 3. So once you do that, the volume for this rectangular pyramid is going to be 315 yards. And it's in, we're dealing with volume, so it's 3D. So we're going to cube our units. Next, we have this pyramid. It's a triangular pyramid because of the base of the triangle, or you might hear it as tetrahedron. Okay, I'm still going to write the formula out. We have volume is 1/3 times the area of the base times height. My height here is 19, so I already see that. So I'm going to go over here and we're going to work on finding the area of the base. So the area of a triangle is half times its base times its height. My base here is 14 of the triangle, so it's 14. And now I need the height of the bottom triangle right here. I don't have a height. I have the 14 meters and I have the 22.1 meters. This is not a height. You need that vertical line right here, which I'm going to put as X. Notice it's a right angle. So this is a right triangle, the base. We're going to use Pythagorean theorem to help us solve. C always represents the length of the hypotenuse. It's always across a right angle. So this is 22.1 squared. It doesn't matter which one you put for A or B. They're just legs. So I can put A squared plus 14 squared. And now we're going to go ahead and solve for X. Take care of your exponents. So 14 times 14 is 196. 22.1 squared will give you 488.41. And now you're trying to solve for X. I know it's squared, so it's different from having just like X, but just treat it right now for this step as X. If it was just X, you would want it to be by itself. You would subtract the 196. You do the same thing. And then you'll have X squared equals 292.41. I don't want X squared, I just want X, so we have to do the opposite operation, and the opposite operation of squared will be taking the square root on both sides. Once you take the square root, X will equal to 17.1. And what was that all this time? This was 17.1. That represents your H, your height. So now I could go ahead and put 17.1 here to find the area of the base. So the area of the base go ahead and multiply, then divide it by 2. So the area of the base is going to equal to 119.7. Now that I have the area of the base and I have my height now, I could go ahead and just substitute it in. And then my height we said was 19. So I recommend just multiplying and then you just divide it by 3. And once you do that, you get 758.1, put the units, meters, volume, 3D, cubed. Now we're going to talk about cones. How do you find the volume of a cone? Okay, so here's a formula for the cone. The volume, it's 1/3 pi r squared h. Notice, if we flip back, I have the 1/3 and the h. And instead of the big B, I have pi r squared. This is the area of your base. The base of a cone is a circle. It has a circular base. So the area of this circle is pi r squared. So that's technically your big capital B right here. So radius is here, your height. You're looking for the vertical height, not the slant height. The slant height is here, so keep that in mind. And now we go ahead and go to do example 3. I'm going to write the formula. So it's 1/3 the area of the base, pi r squared, times the height. So let's see if we have everything. I need a radius. So a radius has to be from the center point all the way to the edge of the circle, which is right here, 9. If you get a diameter, just remember to take half of it. So in this case, that's my R. And this is my vertical height of the cone, so that's perfect. That's H. And I'm going to go ahead and just substitute in our values. So this one's like pretty straightforward. Pi, my radius, we said was 9. I squared times the height, which is 17. Go ahead and do your exponents first. So 9 times 9 is 81. Then I recommend multiply all your numbers with the pi and then divide by 3. And I'm going to keep these rounded to the nearest hundred. So once you multiply, you'll get 1,441.991, and it keeps going. If I want to round to the nearest hundred, I would stop right here. So I do not round up because that number is a 1. So my volume for this problem is 1,441.99 yards cubed, because we're dealing with volume. If you're wondering why example 4 is already worked out, is because I went through it as I was recording, and then I noticed when I watched the video again, it cut off this part, which I don't understand why. So yeah, it's all written down, but I'm going to walk it through still. Okay, so for number 4, we're trying to find the volume. This is the formula. I need my radius. Right here, this is the diameter. So the whole thing is 27. So I need the radius. I take half of that. I got 13.5, and I substitute it in here for r, and I get squared. Next, I need the height. Although you're tempted to see, okay, well, it's 22.5, it's given. That's incorrect. That's the slant height. So let's go back here. So they showed us L, the slant height. We need the height up and down vertical like this. And we don't have that for example 4. So I drew it. And when I do that vertical line, it's perpendicular to this diameter right here, which makes it a right angle. Now, as you can see, now we have a right triangle, so I can go ahead and solve for my height using Pythagorean theorem. Now, because we knew this whole thing was diameter, half of it is the radius, so the length right here, one of the legs of the triangle is 13.5. So I plugged it in. The hypotenuse is across the right angle, 22.5, I squared, and then any leg, doesn't matter the order you put it. You want to solve for your height, so because it's being added, we subtract it over. I get 324. I have h squared equals 324. I actually just need h, so the opposite of a square, I take the square root on both sides, so my height is 18. So now we know, okay, this is 18, and I could substitute 18 back from the formula. I take care of the exponents first, go ahead and multiply by pi, and at the end divide by 3, and this is what you get, and it keeps going. I'm going to round to the nearest hundred, so it's 2 decimal places. So because it's not 5 or greater, I do not round up to 3. So the final answer for this is 3,435.33 kilometers cubed, and that's how you do that. So this video is just the basic, using your formulas to find the volume. The next video, I'm going to do a mixed practice with the cones and pyramids and like some word problems, so you can practice with that.